So presently, we are now focusing on the digital substations. We are now engaging on the AI-driven asset management techniques and predictive analytics and green switches. So all those things we are focusing, as Milind has rightly mentioned, that we are on this journey of digitalization, but this is not yet complete. And for the distribution sector, it is we are far away. But coming to the future power system, the substation role will be very critical, as the future grid will be decentralized, digitalized, and decarbonized. While these transformation brings significant benefit to the system, they also introduce new challenges. With the increasing integration of the renewable energy, distributed generation, power system will face challenges related to voltage stability, inertia reduction, and reactive power management. Because of this, substations in the future will evolve into a dynamic stability center of the grid. And we have to address these challenges. So to address these challenges, we have to come up with the new technologies. Like I will touch few of them. One such technology is the STATCOM. STATCOM nowadays it has been posted by the Government of India CTU, and multiple projects are in the development and the commissioning stage for the STATCOM. So STATCOM is providing very fast and dynamic reactive power support, and it enabling efficient voltage regulation during the sudden load changes and renewable fluctuations. So here in our case, in our country, we are shifting to the renewable. So the requirement of STATCOM is increasing, mainly because of the integration of the renewable. Another key technology is the SYNCHRON. SYNCHRON are in the emerging stage in India, currently tendering and planning stage. Globally, they are already deployed, but in India, recently few tenders has been floated by the Government of India. And this will really help to address the challenge of the low inertia and green strength challenges which are due to the renewable heavy region. It also contributes to the short circuit strength and improve overall grid efficiency. So I can summarize that we have to continue what we are doing with the help of the AI, digitalization. Along with that, we have to be ready with the technologies like STATCOM and synchronous condensers for the future development of the grid. Thank you.
Yeah. Thank you. Got your point, sir. The same if I put to Mr. Atul, sir. Please briefly explain about the current situation of the substation industry, whatever is happening in our country.
Yeah, so thank you. Since we are talking about both distribution and transmission, the purpose defines the state primarily. Transmission substations are connected to, on one side, to large generating stations, and on the other side, they connect to distribution substations. They carry bulk of the power and allowed to be distributed through distribution substations. So there the criticality is more, and therefore the technology intervention is at higher scale. We have better physical instruments like circuit breakers, production relay systems, and other associated systems. But if we come to the distribution part, we have three subcomponents or three levels. One is cities, A grade cities or B grade cities. Then we have suburban kind of city areas, and then the rural areas. If we start with rural areas, then perhaps the physical infrastructure itself is not well equipped to handle the digitalization part or digital connectivity or digital interventions. It is yet to be initiated or thought of, I would say. In some areas under IPDS, we have done some work in uh, suburban areas, and at many urban high modern cities, we have intervention of the SCADA kind of. So, as such, the first task to upgrade the physical infrastructure is in process, yet to be completed. And my view is it requires a lot of huge investments to either replace, make it numerical or digitally compatible, then connect them, then have a sort of IT systems and OT systems to operate in the manner which we, desire or expect. So that way, the situation is evolving, and we haven't reached up to that level from the distribution perspective where we can say that we are ready for digital adoption. Uh, but as I said, that we can start small, like having fault passage indicators that can be done in rural areas, that can be done in suburban areas, urban areas. We have different plans. And then this is from the substation perspective, but we should also have the margin of supply at every substation, because if somehow a substation fails or we don't have the power, then we have at least supply margin from other substations. So that way, situation is, I would say, uh, from the physical infrastructure point of view, from the loading perspective, is yet to come at a stage where we can adopt these technologies in most suitable manner or that meets the objective. So therefore, uh, we could have different strategy in India than the uh, people have in developed world or semi-developed world. Though we are also, in that category at some places, but as far as electrical infrastructure is concerned, in distribution side, we have to achieve much more than what we have as of now. Thank you.
Yeah, got your point, sir. This is to Mr. TP Singh. Mr. Harish was speaking about the challenges. Also, Mr. Atul Singh spoke about that we have not reached up to that level. Ground reality, what we are speaking, current situation, what we are speaking. So, your take on that, sir, if you can explain this.
I mean, this is true. We all know that very well. We have not reached that optimum level. Yes, our aspiration and desire definitely is good. And we have, if I compare that with the last 10 years, yes, we have covered a lot of ground. It's not that the utilities have not put effort and they have not done anything in that direction. They have. I think the only limitation is one, the budget, and second, the will to take, I should say, predictive maintenance and the overall maintenance of the substation and the grid to the highest priority. So naturally, they have their own concerns because at the same time they have to expand also, and at the same time they have to do the predictive maintenance too. So you have to play with both the things because the demand is so high that the utilities have their own challenges for sure. But overall, I'll say that yes, they have done a good job if I compare that in the last 10 years. But if I compare our utilities overall in terms of expansion, predictive maintenance with other countries, even China, I think we are far behind. We have got many, many things to improve. So this will be my quick summary.
Budget is definitely a constraint, but it is traditionally been a constraint to the uh, distribution utilities. All right, transmission utilities are essentially in profit, so it's not that it cannot be done. What we need to think about is that the transmission companies are running at loss levels of around 3%, as we speak, and to go down even, 0.01% requires heavy capex, okay, investment. Now that is where uh, you know the buck lies, so as to speak. So while distribution, I will not touch upon because I think we all know so much about distribution, scheme-driven, downtrodden sector, slowly and steadily coming up, coming back up, reducing losses, etc. But in terms of transmission, definitely there is a big requirement to carry out, you know, these innovative pilots, and also we have already started doing that. So it's not that it cannot be done. The mindset is a challenge, but then we have seen that even transmission utilities are slowly uh, adopting, uh, you know, cutting edge solutions, standardizing their business processes. Many of this is driven by schemes, but some of them are taken by themselves. But at scale, I would totally agree or resonate with what Mr. Singh has said, and that's why I feel that given our condition, our background, and realizing the constraints that we are in as a sector, the first approach should be standardized. So as I mentioned, there is a problem in terms of standardization. So the first thing should be to mandate a common utility-wide architecture. So 61850 for all new substations, and then planned migration to process bus for brownfield sites. This is where you will start spending money slowly, not scare the finance guys, all of a sudden. Second is to modernize your OT backbone and cyber posture. Now, when we say this, your investment into OTN is something which will come, or IPMPLS will come at a later stage. First, you have to go for fiber. There are utilities in India, transmission utilities in India, forget distribution, which are still running, VSAT as a primary communication uh, network. So for that to move to OPGW, they have to have a business case. When I say a business case, it should be a revenue sharing model or a ham model where they lease out that fiber and they make money out of that. When they make money out of that, then they can invest into new technology. So that slow transition should also come in terms of OT backbone. Cyber posture, non-negotiable, not very costly, can be easily done, you know, and that's why the mandate has come as far as the transmission utilities go from Power Sector Development Fund PSDF to implement cyber security operation centers, right? And the third one is, of course, which I have mentioned in my roadmap is automation to intelligence driven automation. That is something which will take time, so I will not talk about that as of now, but that is, we have seen scattered pilots being run. There's an example where dynamic line rating was also done on the stretch from Madurai to Tuticorin by Power Grid. Such initiatives, groundbreaking initiatives are required to be carried out, as pilots or in scale, which can help reduce your operational expenses, which will help improve your top line, right? So if I talk about dynamic line rating, it can, in a nutshell, as a layman, it can help you improve your line loading capacity by 20 to 30%. Global benchmarks have already proven that, which means you do not need to put another substation or another tower, right? So imagine the kind of money you save. That money which you save, you should put into the things that I just mentioned. So that's from my
Transmission guys has the capability. Do you agree with Mr. Milind, and how we can put it further?
Yeah, I agree what he has conveyed. And going forward, what I suggest that we shall do the analysis whether what will be the cost for the post fault condition, what will be the revenue loss, and what if we will do at the predictive maintenance. So all those analysis if we will do, then we can definitely have a better picture. We can have a budget allocation for all these new initiatives. So those things we can definitely take it forward.
Quickly, the thermal imaging camera comes into where the temperature measurement is needed. So, example, just you can equate it with the human body. Whenever there is some problem within us, the first thing happens is the temperature of the body increases, right? Similar situation is with the connectors. Connectors are the weakest link in any substation, wherever you go. And if you go in any substation, let's say if I enter into a 500 kV substation, probably the number of connectors will be 200,000 plus. Now imagine all these 200,000 plus connectors have to work efficiently to give you 24/7 power. And that is not easy. One connector fails, you have the problem. And how will you predict? That is, the temperature will go up, the first indication, like our body. And that job is done by the thermal imaging camera. The second job, which is acoustic camera, is little different. Yes, it can be used in the substation as well, but at the same time, there are multiple connections or the equipments which are generating the partial discharges. And that also creates the problem in the system because that's the leakage which is happening ultimately. And those partial discharges can be visualized with the help of the acoustic camera, not the thermal camera. So this is the fundamental difference between these two products, and both are important.
Do you agree with Mr. Milind that there is no proper standardization? This is what Mr. Milind was trying to explain, I believe. Mr. Atul sir.
Yeah, Millen. Standardization is foremost requirement because of interoperability, because of the substitution of different components. I mean, you as a government procurement process, you procure one thing today, and if replacement is required, you may have another vendor, and that may be supplying a different product. So if it is not standardized and eventually not interoperable, then we'll be stuck with there will be vendor locking. So standardization is important from two perspectives. One is the performance benchmarking. We have better performance benchmarking with the standardized products. Otherwise, if we don't have standardization, then everyone will have its own performance standard. So that's one thing. Second is interoperability. In utilities have large systems, right? And basically we can call it system of systems. So standardization is a requirement where which will be done. I mean, taken up, and government and regulatory agencies will play a very important role to standardize the different products, the processes, and the to basically impart the confidence that utilities buying today will be continuing for the future. So absolutely, Milind has rightly pointed out about the standardization.
Once we are adding more renewable energy, so there will be the challenges regarding the voltage stability and the inertia reduction. Further, reactive power management is also one of the requirement. So to come up with these, we have to come up with the certain technologies. Previously, SVC and other technologies were in place, but nowadays we are focusing on STATCOM, which is very fast and dynamic in nature, and response time for the STATCOM is in millisecond, and it is of two types available in the industry. One is grid forming, which is generally used for the weak grid, not for our country because we have a strong grid. Another is the grid following. So these technologies already now from last few years are in the place, and we here in Regionia also we are working. We are developing 4 STATCOM project. One is in the last stage of the commissioning. Another key technologies which is the need of the time is the Syncon, which I discussed. Syncon will definitely the requirement of the grid as more, and as you told that 50% energy is generated through the renewable. So the inertia from the system is now losing. So to add on the inertia, we have to add on Syncon, and around 3-4 projects are in the tendering stage. Multiple utilities are working on them along with the OEMs. So all these things will definitely help us.
Yeah, so definitely. So few points that I would want to mention with respect to technology, as far as the RE penetration goes, is that we know that the RE is highly variable, right? So there's a lot of requirement of real-time data. Okay. So high RE variability basically makes process bus, SV, PMUs, and precise time sync mandatory, so as to speak, right? That's why there is so much investment around these areas for the need of real-time data. So that's one thing for RE. Then the second point is that the protection becomes adaptive. So low inverter faults, then communications are absolutely critical. You need to have a very robust communication backbone, so that drives the need for having deterministic OT networks, which I mentioned, like OTN plus IPMPLS for non-critical OT traffic, right? RE also increases cyber risks. So this is also one point that I had covered. So the number of interfaces increases. So that means that you have to have a cybersecurity by design as far as you're going for a digital substation. And overall, in a nutshell, basically a digital substation enables RE scale up. It's kind of an enabler because it supports reliability, it supports stability, it supports forecasting, digital readiness for twinning, and at the end, basically moving towards self-healing grid operation.
Yeah, I think this is a very important thing to discuss. Speaking of indigenous technology and products itself, made in India things, made in India solutions. What is the future prospect if I speak of the power system? Basically, focusing on the substation part. This, Mr. TP Singh, starting with you, sir.
Yeah, sure. I mean, Make in India, for us, it is a little bit less relevant because the quantity required is less. So once the quantity is less and then the technology is a little bit high, so for us, from the business point of view, it still does not make any sense. But yes, for the all the other aspect where the quantity is high, for example, all the mechanical parts, it makes definitely a lot of sense to produce in India. The logistic cost is less because for us, the logistic cost is hardly anything. A thermal imaging camera product, the weight of the camera is hardly 1.45 kilograms, and it can come from any part of the world within 2 days. So, but for other aspects, as I told, where the quantity is high, the logistics is high, 100% yes, made in India immediately makes a lot of sense. So that will be my take on it. Thank you.
Yeah, so for going forward, we have to continue our work on the technologies which are available. We have to strengthen them, like FLISR and other operational experiences like DGA integration with the AI. All those things we have to continue. Along with we have to address the challenges of the renewable integration into the system. So we have to focus how we can stabilize the grid, because as we are adding more RE power, the availability of the RE power, timing, and all other things are very different. So we have to continue strengthen our grid by adding technologies, and further we have to learn how to we can adapt and upskill and transform our way of thinking to address these challenges.
Put the perspective of buyers, such as utilities. So there are certain regulations or government uh, directions, guidelines, how to buy, whom to buy, and there are countries which are strategically important from the perspective, and grid is really a very important factor. We have seen recently in many places, and all the war times, grid is the most important asset which powers the war machinery or other important things of economy. So it's a very strategic uh, asset now. So therefore, components of of this grid have to be very carefully chosen. And of course, make in India is important because we can have better controls. We can have, I mean, as per our requirements, and the manufacturers are better aware of the conditions, operating conditions, but simultaneously the quality and the development cycle of the products is also important. And if that is not taken care of, then perhaps the failure rate in field increases, which defeats the purpose itself of digitalization. We are good in software kind of thing, development, but product and dependence on the certain materials may possibly, require some thought over it. And we can have a hybrid or mix and match approach where we can have a comprehensive strategic view as well as the in-house or in-country development. So it depends on the situation and the product and the requirement. So, but of course, Atmanirbhar Bharat is one approach where government is already having a lot of focus.
See, the terminology of critical infrastructure is not without a reason, right? So we have already termed it, globally, that our energy assets are all critical infrastructure. So all components put together, we should be in a position where we are able to do predictive assessment and threat detection before the incident happens. Instead of reactive response, we should be able to we should be able to predict as well as detect, predict, and prevent any untoward incident to plan, on our grid. So this is something which is very important. It is only possible once we are in a position to deploy such technology, which helps us understand such attacks, or attempts of such attacks. And that is why cybersecurity is also one major aspect. Physical security is another major aspect. And the third one definitely is the availability of granular data, uh, which will only enable all of these aspects for us to be able to react. Not react, in fact, to predict and prevent.
I mean, overall, in terms of awareness, if I see, I think people are aware now, more and more. 2, 3 years back, nobody was bothered, but now they are, and more so when the government has suddenly, stopped using all the Chinese CCTV cameras. The awareness even has become more. Each and every person understands why it has been done and what is the rationale behind that. So this is important, and it is increasing. So it has come to a level when everybody in almost all the organization understand what can be at risk. So answering your question, awareness is definitely good. What we need to do, we need to keep us even informed with the latest things coming in the market, because this is an ever evolving field. There will be always new things coming, and to the next challenge is to keep all the people at the same awareness level. In utilities, normally I see people are, mostly people in the field, they are so busy, which is good. They are fully engaged with the job they are doing. They are so busy. The overall awareness of whatever happening is around the world is very, very less. But when something like this happens, like CCTV, then the awareness goes up suddenly. So my final summary to that is, one, the awareness at right now is much better what it was 2 years back, thanks to the current situation which is happening. Second, all people in the organizations, especially electrical utilities, they need to keep their awareness up at the current level or the latest level. That will be my take on it.
Yeah, thank you, sir. Thank you.